Construction drawings, otherwise known as plans or blueprints. You've seen them. They're those huge pieces of paper rolled out in movies and stock footage like this, with architects, engineers, and construction workers pointing and nodding in agreement at certain things on them. And as the old saying goes, a picture is worth 1,000 words. If that's really the case, then construction drawings are worth volumes. You see, construction drawings are a visual representation of exactly how a building is supposed to look and come together when all is said and done. These details range widely, from approximate visual representations of a concept all the way through the nitty gritty nuts and bolts, literally, of a project's final construction. Along the way, we see dimensions, comments about finishes, notes on how certain work is supposed to be done, and too many more comments to address in the intro of the video. But fear not, reading and understanding construction drawings is pretty simple once you know how, although many people struggle with this process when they first get started, myself included. My name is Patrick, your host and the creator of PM Problems, which is the website and channel dedicated to project management, construction management, and other workplace topics. Using my 17 years of experience in the commercial construction industry, I'll be walking you through exactly how to read blueprints step by step so you can understand exactly what the heck you're looking at when you look at a drawing for the first time. Not only will we be going step by step through how to read a drawing, but I'll also define some relevant terminology and discuss various types of construction drawings you're likely to come across, depending on the type of project you'll be involved with. And at some random point in the video, I will give a brief explanation on why they're actually called blueprints in the first place. But I'm not going to link to it or tell you where it is. You must stumble upon it on your own, if you're even curious at all, because some people probably won't care. But before we get into today's topic, I'd like to give a quick shout out to today's video sponsor, OSHA Campus by 360 Training. If you're in need of an OSHA 10 or 30-hour training course and you wish to take it online, 360 Training offers flexible, affordable, 100% online options that you can complete on your own schedule from any device. Check out the link in the pinned comment below to learn more or to enroll today. And now, let's get into today's topic. Now, in order to understand how to read a construction drawing, it's helpful to know the various types of construction drawings you're likely to come across on any given project. To the outside observer, it may seem that only one set of plans represents the entire project from start to finish, where in reality there are many different categories that fall under the umbrella of the construction drawing title. On a large construction site, you may find thousands upon thousands of drawings, for instance. That's because there's just so much information to account for and coordinate. Between drawings that are drafted prior to construction starting, drawings that are produced once construction has already begun, and all of the different trades associated with each phase of the project, working on a large construction project requires an understanding of all the various types of drawings you'll encounter. If you're a homeowner or someone looking to oversee a small project, some of this might not apply to you, but you might find it helpful just the same. Now let's go over some common types of construction drawings you're likely to come across on any given project. This list doesn't encompass every type of drawing that exists, but it covers all the major bases. The first type of drawing you should know about are architectural drawings. Architectural drawings depict the overall intent and appearance of a structure, along with expected dimensions, orientation, and details. These drawings are fairly detailed in terms of the amount of information that they provide, as well as the accuracy of that information. However, they are meant to depict the overall intent and are not necessarily specifically meant for construction. That being said, anything that's actually built is expected to fall within the parameters of what these drawings require, unless otherwise approved by the architect or client. Next on our list are civil drawings. Civil drawings represent the entire site of a project, rather than just a specific structure that's built on the site. Civil drawings often show roadways, drainage, sewerage, major utilities, earthwork, and other bigger picture site details that are also part of the project. And this information is often in addition to the building being built, as we said before, to account for the work that needs to take place to facilitate that construction, as well as the work that needs to happen in the surrounding area. And next on our list are structural drawings. A structural drawing combines architectural drawings with calculations and analysis performed by a professional engineer. These drawings are stamped by a professional engineer and are deemed worthy of construction, meaning to say that if one follows the details shown in them, the building will be built to code and in compliance of what the engineer has deemed necessary. The next category we're going to discuss is actually three separate trades, although they all often fall under the umbrella of MEP, which is to say, mechanical, electrical, and plumbing drawings. Electrical drawings will depict things such as transformers, electrical panels, wiring, fixtures, outlets, and anything else related to power. This can include power required to run machines and other units that fall under the mechanical and plumbing categories as well. Mechanical drawings will depict things such as ventilation, heating, air conditioning, fans, and other ancillary items, not the least of which are thermostats and other controls required to run this equipment. Plumbing drawings will depict things such as fresh water and sewer lines, tanks, drains, sinks, showers, and all sorts of plumbing and sewer related items. And last but not least are finish drawings. Finishing drawings will depict non-structural decorative work. This can include a whole host of things such as sheet metal, tile, woodwork, plaster, moldings, paint, carpeting, etc. While having a general understanding of the various types of construction drawings we went over is important, it's just as important to understand which phase of a project these drawings fall within and how they impact the project's life cycle. Because as you might imagine, different types of drawings are required depending on which phase of the project we're in. So let's go over a few major types of drawings you'll find depending on the phase of the project. One of the earliest types of drawings you'll find within a project's life cycle are design drawings. These can also be referred to as concept or bid drawings, depending on how complete they are in terms of level of detail. Design drawings are ultimately drafted for the purpose of showing the overall intent of what a project is supposed to be. They're drawn by design professionals, such as architects and engineers, before the project is underway. Well before, in fact. The initial set of design drawings is often put together on behalf of the client in order to file for permitting, etc. Once this initial set of design drawings is reviewed and approved by the Department of Buildings, for example, or any other agency with authority over construction, they may be refined to show a bit more detail. The reason for this is that they're ultimately going to be used for the purpose of bidding and pricing by contractors and manufacturers in order to establish costs. And from there, these design drawings will ultimately depict the official scope of work that the awarded contractor is expected to perform on the project, among a host of other key documents. And just to reiterate, design drawings are created and distributed before a project ever actually physically starts. Another type of drawing that often goes hand in hand with design drawings, both in level of detail used, as well as the preliminary phases of the project, are surveys. Surveys are produced by a licensed surveyor, and a survey illustrates information critical to the land on which the structure will sit. And if there's an existing structure that's being modified as part of this project, that is often also surveyed. The survey will include elevation marks at various locations, and by elevation I mean its position relative to sea level, as well as major property lines of the official parcel of land in terms of Department of Building records, along with grid lines, which we'll cover more in a later section, and other information pertinent to the site the project will be built on. Now, once the project is underway, there are still a host of drawings that need to be produced in order to ensure that construction details are agreed to by all and have been ironed out accordingly. The most notable of these drawing types are shop drawings. Now, shop drawings are drawn by or on behalf of contractors who will actually be doing the work. These drawings are produced with constructability in mind. For the most part, they take into account actual products to be used, as well as verified field dimensions and the actual details that will be followed to manufacture and install the work accordingly. Unlike design drawings, which are necessary to show the overall intention of a project before it begins, shop drawings leave nothing to the imagination, or at least they shouldn't. Shop drawings are the real deal. These are drawings, which are often produced and stamped by a professional engineer as well, that are the official drawings in terms of what is actually being constructed. And similar to shop drawings are fabrication drawings. Fabrication drawings are also produced by the company who will actually do the work, but often come after shop drawings are approved. Fabrication drawings are related to work that takes place off-site in order to fabricate or manufacture completed products that will then be transported to the site and installed. Said another way, items depicted on fabrication drawings will become part of the finished work and are supposed to be fabricated to the exact dimensions and specifications of what these drawings show once approved. And as you can imagine, Fabrication drawings include information that's highly accurate in terms of dimensions, exact placements, and angles, etc. And last but not least are as-built drawings. Although the name might give it away, as-built drawings are created to show final in-situation conditions on the project once it's finished. Essentially, as-built drawings depict deviations and changes that have occurred from the approved set of design drawings, as well as any deviations from the approved shop drawings. To put it simply, as-built drawings show what's actually been built once construction is already done. And now before we move on to the next section, I'd like to take a moment to mention that I offer virtual one-on-one coaching sessions for project managers. I'm a civil engineer with 17 years of experience in the commercial construction industry, 15 of which have been in project management. And it is truly a joy to take all of those experiences, lessons learned, and frustrations overcome, frankly, to help other project managers learn, grow, and prosper. Whether you're a new project manager just starting out and you're looking for guidance, or if you're a more experienced PM looking to discuss a detailed topic, I offer both 30 and 60-minute Zoom sessions. Check out the link in the description below to learn more or to book a session with yours truly at your convenience. Now that I've given you this overall information, it's time to dive into how we actually read construction drawings. I will be showing an example drawing soon that we'll look at in great detail, but before we do, let's talk about 4 specific viewpoints that are commonly found on a construction drawing. The first of these views is the plan view. Otherwise known as a bird's eye view, a plan view drawing is drawn from the perspective of looking downward from above at the finished work. As you can see in the photo on the screen, our perspective is looking straight down at the woman who is managing these lovely looking flowers. The second type of view is the elevation view. This viewpoint depicts what someone sees when standing next to the structure, looking at it from a perfectly perpendicular viewpoint. For example, if you walk out your front door and then turn around, you'll be looking at the front of your house, like this photo shown on the screen. From this viewpoint, you're seeing the house in elevation view. The same would be said if you're looking at it from the back or from the sides. But the important thing to keep in mind is that the elevation view shows a perfectly perpendicular viewpoint in the vast majority of cases. But that being said, it can also be useful to have a viewpoint from an angle rather than looking straight on. This is what's known as an axonometric view. Also known as a three-quarter view, an axonometric view of an object is essentially a 3D depiction on a 2D drawing. Take our elevation example from the previous section. Once standing directly in front of your house, looking at the front door, take a walk to either side until you're oriented approximately 45 degrees from the front door, rather than perpendicular. You'll still be able to see the front of the house, but you'll also have a view from the side. And last but certainly not least is what's known as a section view, or a section cut. A section cut is what you would see if you took a large saw and sawed the building, or a portion of the building, in half to view the insides. You're effectively seeing a slice of what that building or structure will look like in the end. And with that, being able to see the relevant details and viewpoints that are not visible from any of the other views we've discussed. A good example of this is to slice off a piece of cake. Although not visible from the outside, looking at the slice of cake allows us to see all of the layers within it. It also allows us to want a piece of cake. Now, before we dive into the main event of this video, let's talk about why construction drawings were called blueprints for so long, and still are from time to time. So as you might imagine, blueprints are no longer blue. Construction drawings have been used for centuries, albeit much less advanced in the past. In the 1800s, a method called blueprinting was developed for creating copies of documents. One must first create a drawing on translucent paper, and separately, a chemical compound of potassium ferrocyanide and ferric ammonium citrate is mixed and layered over a blank piece of paper. The original translucent drawing is placed on top of this chemically coated blank sheet, and a chemical reaction occurs when exposed to bright light. All blank areas of the original drawing become blue on the new copy, while lines from the original remain whatever the color of the blank sheet is. This blue is known as Prussian blue. While drawings are all computerized now for the most part, the name blueprint has stuck and now means any type of construction or detail drawing from a slang point of view. I kind of wish from time to time that they still were blue. but that's beside the point. So now that we've talked about the various types of construction drawings you're likely to come across, the types of drawings you can expect depending on the phase of the project, and gone over 4 basic perspectives and viewpoints used to depict various details on a drawing, let's look at the details of an actual drawing so you can have a firm idea on how to actually read it. For full disclosure, I had to make this drawing myself because getting permission to use drawings officially issued by an architectural or an engineering firm is not always easy from a legal perspective. But as someone who's looked at countless drawings over the years, I can assure you that this homemade version shows enough basic information for you to gain a thorough understanding on how to read it. So, let's dive in. Now, the drawing on screen depicts the construction details for a residential home located at 13 Paradise Lane in Great Falls, Montana, which didn't exist when I made this drawing back in 2019, and I hope it still doesn't. As you can see, there are several images in this drawing, but also quite a bit of writing. So let's start out with the written portions on the right-hand column. This is drawing A101. The A label denotes that this drawing is an architectural drawing, which we discussed earlier. And as I mentioned, the address of this new home will be 13 Paradise Lane in Great Falls, Montana. The owners of this home is the Cardanza family. The architect who drew these plans is listed, and lucky for the Cardanza family, is known as the best architecture firm ever. The general contractor that will be doing the work is Icarus Home Building Solutions Incorporated. And the surveyor that took the marks and produced an initial survey for these drawings to be drafted is Eagle Eye Surveying PLLC. I assure you that coming up with these names is one of the most fun parts of the entire process. Now, just below that, you'll see a section for revisions and changes. So what's that all about? Well, as you can see, there is a brief description next to each of the revision numbers along with a respective date. This notes how many times a drawing has been updated since it was originally drawn on September 14th, 2018. This drawing was submitted to the Department of Buildings on October 31st, 2018. And the architect revised them by adding in grid lines on November 11th of 2018. The most recent revision, which is revision number 3, was drawn on December 24th, 2018. The Cardanzas decided that they wanted an attached garage, so the architect drew this in after the original drawing was made. This revisions and changes section is important because drawings change many times after being originally drawn. And I can assure you from years of experience, working off the most recent version is absolutely essential. Now, below this revision log is the drawing title. In this instance, drawing A101 is known as the foundation plan, dimensions, and details. At the ground level, had these drawings been produced by an actual architect and filed with the Department of Buildings, you'd be able to see their official seal in this blank box. The same can be said if this drawing was produced by an engineer, where you would find their professional engineer stamp. As far as the architect goes, producing this set of plans for the Cardanza family was project number 18-0128. They've also noted that the scale of this drawing is 1 inch for every 10 feet. What this means for you, the one viewing the drawing, is that every inch shown on the drawing by ruler is equivalent to 10 feet of actual construction in the finished work. So if you measure one section within a drawing at 2 inches, that equates to 20 linear feet of actual construction in reality. You can see this drawing was drawn by the architect and checked by the boss, as they often are. And the architect originally drew this drawing on September 14th, 2018. Now, it's worth noting that drawing A101 is only sheet 5 of 63 in the entire drawing set for the Cardanza's property, which suggests, as you can imagine, that there are many, many drawings, 63 in fact, that depict all of the details necessary to design this house in its entirety. And it's worth noting that when it comes to scaling, the drawing must be printed in its intended size, meaning to say that if the scale applies to a drawing that's 24 by 36 inches, it will be thrown out of whack if you printed it on an 8.5 by 11 sheet of paper, which would of course render the scale useless. So now that the written portion of this drawing on the right-hand side of the column is understood, let's review reading the actual drawing itself. I personally recommend always taking a look at the general construction notes first, which can be found on many drawings you'll come across. In this instance, there are a few key notes that are important to know, whether you're the client a builder, or anyone else looking at these drawings. General notes on construction plans typically list all of the information, assumptions, and qualifications related to the drawing that the architect feels necessary to convey. On drawing A101 here, some of this information includes that all dimensions are to be verified in field, meaning verified in field by the contractors doing the work. The drawing also notes to refer to structural drawings for final dimensions of components. There's also a qualification here stating that drains, utilities, and fixture locations are not final, at least at the time that these drawings were released. And last but not least, it makes note that grid lines are drawn in accordance with the land survey provided by Eagle Eye Surveying. As a little side note, this is an example of what one means when they say that drawing sets are to be coordinated, because drawings will frequently refer to each other in terms of details. Next, it's crucial to review the drawing's legend. The legend summarizes what all symbols, textures, and icons on the drawing mean, because they won't always be labeled with words. The legend on drawing A101 notes the symbols for slab on grade concrete, typical foundation viewprint, floor drain, elevation marks, and sand and gravel, because these are what will be depicted in the various visual portions and details of this drawing. The legend should be referred to whenever a symbol or icon is not expressly labeled or understood. The compass here notes the orientation of the house relative to magnetic north, or true north, the same north that's seen while viewing a traditional compass while navigating the woods, for example. Now let's talk about the visual parts of the drawing and what they represent. As we briefly covered before, construction drawings are made up of a series of details, which can also be described as a series of viewpoints and perspectives. On drawing A101 here, detail number 1 shows the basement floor plan. This plan view drawing shows the dimensions of the main house's foundation along with the garage's slab on grade foundation. One can see that the foundation for the house measures 40 feet by 47 feet, while the garage measures 20 by 25 feet. Also take note of the GL labels. Like we said before, this stands for grid lines. As the revisions and changes log notes, these grid lines were added to the drawing in revision number 2 on 11/11/2018. Grid lines are used like a map. They're meant to help the viewer locate various components relative to a known mark. Kind of like in the supermarket, a staff member may direct you to aisle 9, section 12. That doesn't tell you exactly on which shelf or in which box you'll find what you're looking for, but it does tell you the general area where you should be looking, within reasonable accuracy. You may notice how these lines run along the exact edge of the house. On a job site, these grid lines are often marked using stakes in the ground, which are placed by the licensed surveyor at the time of taking their survey. They serve as an easy reference to determine where a wall or component of the house needs to be built relative to this baseline. Adjacent to the garage are some brackets and a number 3 inside a triangle. So what the heck's that about? Well, the number 3 corresponds to the revisions and changes log on the right that we looked at before. Revision number 3 notes that the garage was added to this drawing on 12/24/2018. And the number 3 inside the triangle outlines what was actually added. So this notation will be used to correspond to any changes that are made in that particular drawing set, with the version shown on the right-hand side. Now you might be wondering, what are these strange marks labeled AA and BB? Well, like we spoke about with the slice of cake, these are known as section cuts. These marks depict where a section cut detail is taken. And as the old saying goes, the devil is in the details. Construction drawings are certainly no different. A detail is exactly what it sounds like. A portion of the drawing that provides more detail and additional information that simply can't be seen looking from afar. Details are almost always close up and drawn from a specific perspective. When looking at a section cut symbol, the arrows depict which direction you're looking when viewing this detail. And as a general statement, details in construction drawings either give a close-up perspective, a different perspective, or a combination of the two. So back to these callouts labeled AA and BB. Section cut AA is labeled as typical wall section for the foundation. This is what the foundation looks like when slicing out a section of it, like we spoke about with the piece of cake. The top of the foundation will sit at 3,330 feet above sea level, which is of course an elevation of 0 feet. The bottom of the foundation will sit at an elevation of 3,325 feet, meaning the foundation is expected to be 8 feet tall, which is of course what we get when we subtract 3,325 from 3,333. Other information shown in this section cut includes the width of the foundation, which is to be 12 inches, and the thickness of the floor slab in the basement, which is to be 6 inches. If the wall in this detail was drawn to scale, it would take up too much of the drawing. That's why there's a horizontal zigzag line through it. This basically says that the wall looks no different in the portions that aren't shown, so you can skip over it for the portions of understanding what this detail is supposed to show. And section BB is just like section AA, but in the garage's foundation, not the houses. This notes at the final top of slab elevation as being 3,332 feet, which is 1 foot below the top of the house's foundation. And as you can see here, the slab is supposed to be 9 inches thick with another 9 inches of gravel and sand beneath it. And now that we've gone through an actual example, step by step, of what a construction drawing looks like and how to read it, let's finish this off with a few rules of thumb that I've used over the last 15 years that describe the general approach necessary to reading construction drawings. The first tip I have to give is to think big to small. I recommend getting a good handle on the biggest, broadest, most overall details first before diving into any of the specific details such as section cuts, etc. It's also important to understand that drawings are not perfectly coordinated. Architectural drawings will show some information related to the structure, but not all. This is because multiple parties are responsible for producing their own drawings and the details relevant to the portion of the work that they're handling. The plumber, for example, is not concerned with getting every architectural detail right, nor are they responsible. And in the same way of thinking, the structural engineer producing structural drawings is not necessarily thinking about the details of the lights in the garage. That's why it's important to look at the appropriate trade set of drawings for the most accurate information related to that portion of the work scope. And as a builder or client, it's helpful to have coordination discussions with the various parties involved to iron out any loose details and discuss any questions that each party may have to make sure the necessary details and information are being coordinated appropriately. Another tip is to always make sure you're using the latest version of a drawing. Construction drawings get updated all the time, and believe me, you don't want to get halfway through building something only to find out that you were looking at an old drawing. I've definitely brushed up against this situation before, and it's 1 out of 10 would not recommend. And like we've said already, referring to the revisions and changes table on each drawing is key to make sure that you're looking at the latest set. Another tip I have is to make sure the drawings you're looking at are stamped. I have to give the disclaimer that this isn't always the case. For instance, if a drawing is depicting carpeting and paint, it doesn't require an architectural or engineering stamp. But the general rule of thumb is that if drawings aren't stamped, they're not legitimate for construction, for all intents and purposes. That's because any drawings that are deemed legitimate for construction have been filed with the Department of Buildings and permitted for use. So generally speaking, it's worth at least inquiring if there is a set of stamped drawings available before you ever begin any work. And my last tip is certainly not the least, and in hindsight, I very well could have put it first. Refer only to structural drawings for actual component size, type, and assembly when it comes to doing any work whatsoever to the building's structure itself. Which is to say, any portions of the building or structure that are actually holding it up and keeping it stable, in comparison to details related to non-load-bearing portions of the work or finishes, etc. Before building anything in reality, always refer to drawings put together and stamped by a professional engineer. And if you're asked or required to do any work to a structure that hasn't been stamped, I would highly recommend not doing that work until it is. I hope you found this video helpful and informative on, well, how to read construction drawings. And who knows, maybe even have a laugh or two along the way. Now, what do you think? Do you have any thoughts or comments on what we discussed today? Please feel free to share by leaving a comment below. And if you enjoyed today's video, giving it a like and sharing it with someone you think would find it helpful would be greatly appreciated. And if you'd like to stay in touch for future videos, please consider subscribing to the channel for updates in the future. Your support does not go unappreciated. And lastly, if you are interested in one-on-one project management coaching sessions, be sure to check out the link in the description below to learn more or to book a session at your convenience with yours truly. So I hope to see you around again. But until next time, this is Patrick from PM Problems signing off, and cheers.